In 1865, the Hawaiian Kingdom instituted a policy of forced segregation of persons affected with leprosy. Leprosy had reached epidemic proportions in the islands and threatened the eradication of the native Hawaiian population. With no knowledge of what caused the disease and no cure, isolation seemed the only answer. The Kalaupapa Peninsula on Moloka'i was selected because of its natural isolation. To the south, the peninsula is cut off from the rest of Moloka'i by the 2,000-foot-high Pali, or cliff. The ocean surrounds the east, north, and west sides of the peninsula. The peninsula land could support people. Vegetables such as sweet potatoes, fruits, and taro could be grown. The ocean and tide pools provided food, and fresh water was available from Waikolu Valley and Waihana Valley. Mandatory isolation ended in 1969. The Pali Trail provides the only land access to the peninsula.
Before I go into the projects, I'll just have a brief introduction of myself, especially some of the academic training that I have received, because some of the approach that we use seems to be a little unconventional. I was talking to Professor Papakostas. Some of the technical approach that was used was probably, looking back, it was like a typical master degree class exercise where I got my education. So I was first born in Hong Kong, and before I finished what they call secondary school, which is high school, I went to London and finished my O-levels and A-levels there. Then I got into University of London, did my degree. First degree was in geology, and after that I applied to Leeds, University of Leeds. They have a master degree course that called Engineering Geology and Geotechnics under their Engineering Geology organizer, and it's half the course was, I remember, application of geology to engineering project. The other half was spent at the Department of Civil Engineering studying soil mechanics, the mining department for rock mechanics, and so on. And I think they provide a very good fundamentals for us to being to integrate subsurface conditions with engineering properties and engineering situation. After that, before I left, they told me it looks like I can work independently, and in Hong Kong there was a lot of landslides that killed a lot of people every time there was a rainstorm. Asked me to do my PhD part-time, and I agree with the condition that I have a local supervisor, and I got a civil engineer. He's got his PhD from Cambridge, John Annicott, who helped me a lot. That's what I did my PhD on, is primarily on the geotechnical properties of weathered rocks and its engineering geology, figure out why some slope failed and why some slopes stand up even though they are very steep and they're in soil-like material. After that, then I worked in Canada a little bit. Back in 85, Geolabs brought me to Honolulu. I want to work with Professor Ed Cording and Jim Mahar from University of Illinois to learn about tunnel investigation. After that project's done, then I worked for Dames & Moore with SK. A lot of you probably know him. And I was sitting next to the architect that we work on one waterfront tower. That was my first deep foundation project working on the SK. After that, went out with Pacific Geotechnical, and then URS hired me to start a geotechnical and construction management group. Since then, we were bought by URS, and 5-6 years ago, my partner told me was that he didn't think he would be able to work till his retirement, so he asked me to join him. I said, no, I don't want to join you. They're treating me well. So he said, you're next in line to run the office. So I said, I'm getting out of here. We started Yogi Kwong Engineers about 5-6 years ago, and a lot of projects that Gary mentioned, I think we started out from the Pacific Geotechnical Engineers Day through Wilbur Clyde and URS. This project, around about May or June 2010, I think the National Park Service gave me a call and say, we have a situation on the Pali Trail leading down to Kalaupapa. They already have retained a contractor, design-build contractor, Oregon Woods from Oregon. Their team, they have a structural engineer, and they drove some rebar in the ground and said, it's hard, let's build a bridge on it. But National Park Service, quite often, one of the blessings that we have as designer is that the owners have their own professionals and they're sophisticated. So they knew that this is not adequate because they know the trail, they know the history of the trail. They called me up because we were on open end, I think with Kennedy Jenks, that's how they know us. and asked me to look at it. They said the contract is out, funds are limited, what can you do to help? They didn't think, they're worrying about the foundation, they're putting in a replacement bridge. I need to get back to him in a couple of days. So I slept over it at night and then looked at the geological map that's available and some of the site photo he sent me. I told Scott Henderson, I said, Scott, it looks like, and of course the people running the mule trail, and there are people walking up and down the trail every day to go to work down at Kalaupapa. So how do you get it started and help me to stay within budget? And we're in a rush because the mule train guys are going out of business. I told him that if you agree to have a backup plan, we would do this. I told him that we will, it looks like if we don't know what kind of soils, you can see these are fill. And I think after we clear the vegetation, at first they thought the rocks were a little higher, but after they clear the vegetation and then you talk to the park service guy, that these were some of the patients living down there. They used to have a gate right at the top, so they cannot come out. But this was all hand-packed cobbles that they put in. And the location was, there were 3 transient waterfall coming down, and it was just washed off. April 13, 2010, the transient waterfall just washed part of the bridge away. I told him that it looks like the rock on the side, we don't know how deep rock is. If you agree that if I need to, I would nail the entire bridge on the Pali slope in the rock. And in the meantime, I can get you a contractor out there that I know that has equipment, a helicopter can lift, and he can tether his drill rig on the slope by putting in bolts on a rock slope and use cables to hang the drill rig. And I can install and test micropiles. If the micropiles work, then the bridge can be partly supported micropiles by micropiles and partly by rock anchors. But if not, then you have to prepare to get your structural, to design a structural bracket, and we'll pin the entire bridge on the cliff face, assuming there is no support underneath. Scott verbally agreed that can give me a number by the next day. It was a quick number, so fee was low, right? That's 30-something thousand for me. And I also get a quote from Janot, because we worked with another tough job before, and they come up with a number real quick. It was, I think, somewhere around $100,000. They kind of share the same type of work ethics that we have. I think they just give you a number, and they like emergency work. So that's what we did. Just a quick email, they agree on a number, and we went out and we looked. One of the first things we have to decide is where to put the micropiles and the anchors, and the more we look, the scarier it looks. So these are all fill. With a lot of back and forth, actually it happens all within one day with Oregon woods. We picked a couple of locations. There is better rock there, but that means that we have to have an aluminum bridge. This is a 2,000-foot high cliff face, and we're about 100 feet down from the top. That means we can build a 90 to 100-foot long aluminum bridge, but spend way out over the Pali. And it's kind of scary for us to stand there, but imagine a mule train going through and the bridge swales. So we say, don't do that. Let's keep it short. So they ask for 50 feet, and we say, well, let's make it work. So we spent a lot of time trying to fit that in, and finally we did. And this is Janot, that's Pierre. He's from Quebec, but he lives here now, putting in some of the anchors. And
before you switch to that, you might point out that there's Kalaupapa village down in the corner.
Very good. Yes, they're down there. So
was the original thing that washed away, was it a bridge or a trail with a foundation wall or something?
Very good question. It was like a wooden bridge. Actually, you see a small part of it there, and part of the bridge was built temporarily by the National Park folks. When I show the video, you see that they first, when they actually put the new bridge in, they would first took off the temporary bridge that they put on, and then they took out the remnant of the old bridge. So what you've seen in there is this part is the old bridge, and this part was a new one because the old one got washed away, and they have to build it through so that we can walk through. It was very spooky because it's just 2x4s and 4x4s sitting on loose fill that's all cracked up already. There's no foundation, nothing. And we were moving equipment back and forth. All these were dropped up by helicopters. One of the agreement was that we will use the drill hole to install. So we have to put a bet on how deep the micropiles need to go. So we ran some initial calculations, how long the anchors needs to be in order to support the bridge and to tie it down. And because all those casings, number 9 bars, and the amount of cement to grout the hole has to be pre-ordered and shipped over. So we made an initial estimate, and Janot went out when they drill. And the agreement was that when they drill, we'll look at the ground and the soil conditions, and if we need to make it longer, deeper ant numbers, they agreed to back us up. And we went out and we drilled these. The cones show where the 2 micropiles are on this side. Over there, because the soil is a lot deeper, we have to move them closer together, like here, and these are the 2 anchors going in, and that's the number 9 bar going in. Of course, we have to check whether based on the length that was selected, whether we picked up. We have the pull loads. It's a remote area. We cannot put in a vertical compression load test, so we did a pull test instead to verify. One thing about doing a load test in a remote area is, especially with this test, when you try to pull it out, the ground was not firm, so it went through some movement before it stopped. So.
It was friction tire?
Oh, it's basically friction. The micropiles and the rock anchors, they're totally relying on the bond length. It's a 4-inch casing, and as usual, you tell the contractor to get a 4-inch casing. So, I thought it was 3-inch. I thought it was 4-inch nominal. And then we will scramble and do a bunch of calculations and say, okay, let's put it deeper. Do you have more? And he said, no, I don't have more. So I said, okay, let's see what we've got. And this is an example of the drill rig. They tie it up with cables and ropes. Basically, helicopter dropped it down, and when they need to move it around, they have to bolt it, and then they just move it like a spider. They just tether it on the cliff face.
So there's Kalaupapa Lighthouse there in the corner too. Wait, just barely make it out.
Correct. It's a beautiful place to work, actually. Yeah. Yes. Watch your back too, because if you're not careful, you just fall right off the Pali. So this is a plan, and there's a little bit of story behind this, because we went out and there was a sketch, and it was made to scale, but I told the structural that I'm going to put not to scale. A lot of emergency design build work. It was so hard to get a contractor, to get a survey crew to pin everything down. So you have to lie and say, no, nothing is to scale. You have to verify that. I don't want a helicopter to drop your bridge and it didn't fit. Okay, so all this was measured, and I told the structural that the original layout was not correct. They're not squared. They are what they are out there. So these are the 2 that we have to get closer together, because if we were to drill here, they would run out of casings and number 1 bar. And these are the rock anchors, and the angles are determined by no magic, is where they can fit the drill rig. Okay. Same thing here, and these 2 got in as planned. And these locations are some of the core holes we're trying to core to get some rock samples, to get some unconfined compressive strength and dynamic cone penetrometer, get at some blow counts and correlate with the friction angle of the fill.
That's a plan view.
That is the plan view. Yeah, thank you. And we got an amazing structural engineer who took a sketch like that, turned into beautiful drawings. I forgot who at Nakamine Okawa engineers. So that's a micropile, and those are the anchors. And they put it on. It's a 50-foot long aluminum bridge. The anchors, I told him that they are not laid out properly, so that he needs to take care of all that eccentricity. The 2 shorter, closest base micropiles.
Could you define the micropile in terms of how long it is, how deep it goes, how big it is?
Oh, very good. We use a 4-inch diameter drill bit, and we drill down to about 25 feet or so. And then they would put in the 3-inch, probably just a little bit over 3-inch steel casing, galvanized, and then we'll put in a number 9 rebar and grout it, endless, and outside. So it's very slender. It cannot take much of a lateral loading. That's why we need the rock anchors. And the rock anchors are there to at least hold up the bridge if the fill was eventually or maybe eroded. We told the National Park Service it's important to shotcrete and protect those fill, but they don't have money to do that. They said they'll try to program it in. I think at this point they're going to just observe it to see whether there's going to be signs of future erosion, and if not, then they'll probably leave it like that. The rock anchors is basically just drilling with the same 4-inch diameter rock bit, and they put in almost a 1-inch thick bundle of steel cables with centralizers and then grout full length, and those were tested too. And that's the completed bridge right here, and that's the transient waterfall, and that was just a part of the enormous Pali slope.
The pasture above the trail there, huh?
Correct.
Just to get located.
Yes. Yeah.
And the highway is just off.
Highway is just off. You can actually park near the gate and then walk through, and you can just walk down. There's a sign that says you have to get DOH permits or something to go down there, but you can just park there. Yeah, just park. Most of the worker who works down Kalaupapa, they just park on the road and they just walk down.
Another interesting thing right in that area is the one and only 1-hour meter that Moloka'i Electric reads. They bring the kilowatt hours up to the edge of the cliff and dump it over.
It's DOH because by law the director of the DOH is the sheriff in Kalaupapa or something like that.
That's right. And that's the mule train company. They were testing the bridge to make sure that the mule, I guess for those of us who ride horses or mule, they are very smart, but they are very sensitive to differences in a trail. Yeah. So they were testing it to see if it's...
That's the new bridge?
That's the new bridge. And I'll show you some video how they got in. This one is just to show the actual location. And I'll show you some video how basically the Pacific helicopters. I always enjoy working with this ex-Vietnam helicopter pilot. When he was dropping off our equipment, he flew out there with his helicopter after the load. He just made one circle, and then he did a straight dive all the way down. Just before he hit bottom, he turned up. It was so fast. I caught it on camera, but you can barely see the helicopter. But you see his skills in this next videos.
Was that picture the old bridge up in the corner? Is that the bridge?
This is old bridge. This is new bridge. Old bridge. This is new. And I'll show you a bigger poster. I can zoom in. This is demolishing the temporary bridge. Helicopter is up there with the cable. They're running away. Yes, correct. That was a temporary bridge that National Park Service has put up. And then the next one is the taking off the whoops. They're taking off the old bridge. This guy's cleaning out the bridge abutment because the next load will be the new bridge. Those are the ones we put in the micropiles and the anchor, and there was a reinforced concrete abutment that the structural and the contractor put in. There was no foundations there before. It was just hand-hacked cobbles.
How old was that bridge?
How long?
How old?
It was, they probably replaced it because the trail is like over 100 years old. So they probably replaced it with time.
And it was during a storm that material fell down and overwent, loaded, and it collapsed, or the edges wash out.
It was during the storm that it was washed out, but there are loose rocks that needs to be trimmed, and there are loose rocks even there now that they didn't have money. Oops, that was one too early, but the bridge is already lowered. I'll show you the one, and you can see the skill of the helicopter pilot. This is our helicopter lowered, and see how he did it. Put it right on the trail. He used the shape of the Pali. He's done.
What was he lowering? What is that?
It's a helicopter.
No,
Those are planks.
Planks, it wasn't planks.
Yeah, see the bridge was lowered. I should show you. I'll show you how he lowered the bridge.
Okay.
You thought that was amazing, but this is. I couldn't believe my eyes. How. Now he has to place it on those two abutments. There's not much room for error. And that's just a helicopter pilot.
What's the bridge weigh?
I think his helicopter can only lift maybe 1,700 pounds at that altitude. Yeah, that's why I wonder. Yeah, but he you see, he just dropped it right there and he's done.
He's watching this camera.
and he's done. So I want to show that because for a project that happened so quickly and so smoothly, I think there are a lot of outstanding work by the contractor and the owner and other team members, and I just want to show what the National Park Service says that makes it all worthwhile.
So how long did it take to start to finish?
The entire fix was 6 months for our scope. Doing the initial investigation and load test was just 2 weeks.
Where did they assemble the bridge? Up on top or at Honolulu and ship it over?
I think a part of it, all the material came through from Oregon, and they barge it, and they probably assemble them down in Moloka'i, and bring it up. There's a park nearby at the top, and a helicopter just pick it up from the top.
So it trucked it up from Kanakakai, huh?
Correct.
My late wife grew up on Moloka'i.
Oh wow!
How long was the period where they couldn't go with their mules?
Without the meals,
Yeah, but
the meals is off.
how long was it when you couldn't go back and forth?
How long was the trail closed?
The trail would close on all for that 6 months. But people can walk, but the trail cannot walk through those temporary bridge. And the trail was officially closed. Only the folks who work down in Kalaupapa and have to walk up every day, they walk up and down every day. You still see some really chubby guys. I don't know how they stay so chubby when you have to walk that distance.
How long would it take one of those guys to walk? 1 hour hike?
For me, to hike up was a little over an hour and a half. Yeah. But what Scott Hendrickson said was make it all worth it, and he said, as remarkable as the engineering, in my opinion, was the fact that we funded, planned, contracted, completed, geotech, installed piles, designed, fabricated, shipped, and placed a bridge in a span of 6 months, unheard of in our government system, but a result of everyone doing their part. So, thank you very much.
Questions? 5 minutes. Questions? Is there any further work on the trail plan?
The National Park Service, they always look at it. I think they have plans because there's still a lot of loose rock on the Pali.
But most of the time they try to take care of it themselves because they just don't have the funding. And I guess the more Congress squeeze them, the more they have to do it themselves. So, but they did ask us, what do you think? What do you think? And I told them, well, this area you need to look at. And I think in preparation of these award preparation, I flew over from Maui with a helicopter, took a bunch of pictures of the Pali, and I gave him those pictures. He probably used that to plan some of his maintenance work.
I understand, in fact, I was talking to Park Service people just this week, and they're still having a bit of a debate as to how they're going to operate the Kalaupapa National Park after the last patient leaves.
Correct.
I think there are 11 qualifying patients left.
Right.
And if it's a national park, it has inherent limitations that we just saw in terms of access.
Yes.
And so I don't really think they need to be particularly fussy about limiting access because there's only so many people have either the dollars to fly in or the guts to hike down.
Correct. And but I think that the so-called DOH restrictions because there's patient down there.
Well, that's for now.
Right.
After the last
When they're gone, I think people with the Catholic faith, I think they go there. I think there's probably a steady stream of people that goes in there. You can see chartered flight going in a couple of times a day.
And not only that, there is the Congregational Saloma Church right there near
I see.
Both were involved.
Yes. And it's quite an experience walking down and look at the Pali and walking up. It was, and you see the goat. There's some mountain goats by. I think that was his territory. He hangs out on the trail. Scary things, about this tall with the horn.
Bill, do you have a question?
Yeah, when
Excuse me.
it's possible that to supplement this bridge and all, have a cable car and put it all the way down, but people just don't want to fly down there. It costs too much maybe or whatever. But just a cable car, like.
Well, that's what your note said. Pay me and I'll put a zip line right there.
I think what would happen if they put in a cable car, then they would have to have formal limitation on access.
Correct.
But if they don't put in the cable car, I don't think they need to worry about that limitation.
Yes. But it's a beautiful place. I think if somebody can, if the last patients, it's not there anymore, then some overnight facilities is a beautiful place. I think they have a problem with the pier because I know that at first they're trying to fix it because certain time of the year, depending on the waves conditions and direction, young brothers cannot moor, and young brother doesn't want to go there. They lose money going there. So, but it's a beautiful place.
Someday they'll have mule service now.
They have mule service going down every day.
Sounds like the way to go.
No, it's less scary to walk because on the mule you're like 4 feet higher, and you're at the mercy of the mule. With the mule, so you're one of the brave guys. I just walk.
Shouldn't the mule companies pay something?
No, they were just screaming and say, "When are you going to open? You're hurting me." That's all they do. Okay, we good? Okay.
Can you explain what it is?
Yeah, okay.
Okay, congratulations. Thank you very much, James, and that's for our appreciation talking to us. It's a fantastic project that they did. It's, to me, the ultimate in engineering design, being able to think on your feet, because geology, as you all folks all know, is a moving target. It's not same every step you take. It's different. So that's why these guys did a fantastic job. Yes. Anyway, like Jeff said, next week we're off Kuhio Day, and then the following week, the last Friday of this month, we will have Lieutenant Colonel Jan Macedo. She's with the JAG, and she's going to talk about justice in Iraq as part of her experience. So that's the last Friday this month.
Thank you very much. Is she going to talk about my JAG? No, different JAG. Anyway, thanks for coming, and we'll see you in 2 weeks. Meeting closed.